Today we are going to use graphs to determine if something is linear or not. By now we should already know what linear means. It means it follows a line. So there are two characteristics of linear. One, there is a constant rate of change. And second, it's awful to write with a mouse. Second, it will be a straight line when graphed. Okay, so let's talk about this problem. It says linear or nonlinear. The population of a city increases by 5% every year. Suppose the population in Jeff for 2019 is 1,000 people. So we need to find out if there's a constant rate of change, because that's the first thing. And then we need to determine if it's a straight line. So we need to find out what 5% of 1,000 people is. Well, I have 100% of my population is 1,000, but I have to add 5% to it. So to find 5% of something, I'm going to take it times 0.05, because that is 5%. So 50. So that means that the new population in 2020 is 1,050. Okay. So then to find out the next one, I need to figure out what 5% of 1,050 is. So 1,050 times 0.05 equals 5,250. So now I need to add that to the 1,050, which will be 1,102. All right, next we need to find, it's going to increase again. So I'm going to take that new population and I'm going to multiply it by 0.05. So 1,102 times 0.05 equals 55. Something doesn't look right there, so I'm going to redo that. 1102 times 0.05, 110. So, no. 1102 times 0.05 equals 55.1. Well, we can't have 0.1 of a person, so we're going to have to round that to 55 people. And I need to add those people, the 55, to the 1,102, which will turn into 1,157. Now again, population is going to increase. So 1,157, I need to figure out what 5% of that is. So I'm multiplying it by 0.05. No, 0.05. And I get 57.8. So that's almost 58 people. So I need to take that original population, 1157 plus 58. I could use a calculator. I would encourage you guys to use a calculator. I got 1,215, or 1. So in answer to the question, is there a constant rate of change? The answer is no. The second part of the question is to graph. So we are going to have to make this a straight line or a graph when graphing. So we have to label our edges here. Let's see if I can get a color for us. So we'll make this 2019. We'll make this line 2020. We'll make this line 2021. Make this line 2022. This could be 2023. Now, looking at how they are counting, I have to get 220. So let's start at 1,000 right here. And let's count by 20s, I think. 20, 40, 60, 80, 100, 20, 40, 60, 80. So that'll get me close to where I want to go. Let's try it. Let's count by 50s. We'll do 25s. 1025. So this one is 1050. This one is 1075. This one is 1100. This one is 1125. 1150. 1175. 1200 and 1225. And now we plot the points. So I'm going to do that in blue. In the year 2019, it was 1,050. So I'm putting a point right there. In the year 2020, when 2019, it was 1,000. So that goes here. So forgive me. Erase. Okay, there we go. So in 2020, it was 1,050. In 2021, it is 1,100 and a little bit. So I'm going to put that dot just a little bit above there. 2022 is 1,157. So 1,150, it'll be about right here. And 1,245, 1,215 would be here. So let's prove that this is not really a line, even though it does look like a line. It is definitely not. If I take this and I graph it, that will have a slight curve to it. So if I start here and I go up to where it's supposed to be, there's a slight curve to it. The other way that I can tell is because these are not the same change every time. It is close, but that change, as you notice, went from 50 to 51. And since it's not a constant rate of change, it's not going to be a straight line. So the answer to this would be no. So that one is non-linear. So I would assume we're just going to circle that right here. We'll do the second one in just a second. All right, we're going to be finding out the same thing. Is this one linear or non-linear? Remember, we are trying to find out if there's a constant rate of change and if it's going to be a straight line when graphed. So he runs 3 miles every 20 minutes. So in 3 miles, it takes 20 minutes. 6 miles, that will take him 40 minutes. 9 miles will be 20, 40, 60 minutes. 12 miles will be 80 minutes. 15 miles will be 100 minutes. Yep. So now we have to graph online. Is there a constant rate of change? And it looks like there is. This one is 3 over 20. This one is 6 over 40, which reduces to 3 over 20. This is 9 over 60, which also reduces to 3 over 20. So you can see that this is just like our unit rate problems that we had, where if they reduce to the same fraction that they are equivalent, and that means it's a constant change. You can also kind of see this counts by 20s and this counts by 3s. So since that is accurate, that works. We are going to do our graphs. 3 will be here, 6, 9, 12, 15, and we will count by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we can do that. 10, 20, 40, 60, 80. Oh, said I was going to count by 10s, and then I counted by 20s. So erase what we just did. This should be counting by 10s. So 10, 20, 30, 40, 50. I think you're getting it. I don't need to keep saying it because I think it's messing me up. And now we're just going to plot our points. So 3 and 20. 3 and 20 would go here. 6 and 40. 9 and 60. 12 and 80. And 15 and 100. Again, you're going to be able to use your line. You should use your pencil. I have to use a calculator or a computer. And you will connect like so. So the answer to that question, well, that's not perfect, but you understand what I mean. So the answer to our question is this one. The answer is yes. It is linear. So we're going to do the other side. You guys will work independently, and then we'll go over it. So we need to try to figure out what are some things that might be a clue to say whether it's linear or not. The thing I want you to notice about this side is that this one tells us 3 minutes every 20 miles. The other one had a percentage, and so that percentage made it change. So that's something I want you guys to think about.